Unit 6. We're going to focus on different type of graph. Okay? We focus on different types of graphs. They're in different units. Looked at lines, linear equations. That was early on, Unit 2, I think. I don't know. We looked at absolute values, their graphs. Now we're going to look at quadratics. Quadratics. What is a quadratic? It's like this guy down here. It's a y equals x squared plus x minus 6. When we have x squareds, we have like x's sometimes, numbers. Great. And our goal, for the most part in this unit, is to solve these quadratic equations. Like this equation, x squared plus x minus 6 equals 0. Go ahead and solve that. Some of you will be like, I know how to do this. Some of you may not. Give it a shot. Solve x squared plus x minus 6. It's an equation, right? So we try to like get x by itself, right? Let's try to get x by itself. Yeah, we like add 6 and we got x squared plus x equals 6, but it's like, man, I got 2 x's there. Square root both sides, maybe? Yeah. No, you can't do it. Okay? So it's different. So we're not going to be able to solve these equations like we solved regular equations by isolating a variable. We can't isolate x when we have x squareds and x's. We need a different approach. Okay. Isolating x, not possible. Now, let's look at the graph of x squared plus x minus 6. This is what it looks like. They end up looking like these U's. I'm sure we've seen these before. Okay. Now, if I asked you, where are the zeros? What would you look for when I ask you, when does a graph have a 0? Discuss with your neighbors. What does it mean to be a 0? Discuss. Shoot out possibilities to your neighbors. Yes, zeros are the x. Zeros are the x-intercepts. Zeros are when y equals 0. Okay? Now, what does it mean to be a 0? Well, here we see a 0 at x equals -3 and x equals 2. You see both zeros here and here? Yep. Okay, good. Now, what does it mean to be a 0? Well, if it's y's are 0, I have this equation. If my zeros are when y is 0, and I plug in 0 for y, I get 0 equals x squared plus x minus 6. So all of a sudden, what we had at the beginning was the question, solve this. Well, I can kind of see the solutions by looking at the zeros. So it's a solution to this equation. So what you're doing when you're finding the zeros is you are solving 0 equals x squared plus x minus 6. Now, another word for a 0 is a root. Root. Not R-O-U-T-E. Root. If I ask you what is the root, you would say it's an x-intercept. It's when y is 0, solving this. Okay? Okay. Now, can we solve this? Well, it's kind of where we ended up with the previous problem. What I'm going to tell you is that when we have x squareds and x's, you do not want things on both sides of an equation. What you want to do instead is make sure everything's on the same side. Now, when I subtract 14 from the right side and 14 from the left side, I get this. Now, if I had a graphing calculator, I could graph this and look for the zeros, right? Like I saw in the graph of the previous situation. Do we have graphing calculators for this class? No. So we cannot graph this, okay? So I could graph y equals x squared plus 5x minus 14 and look for the zeros. And your graphing calculator has multiple ways that it can find even like decimal values if there are zeros. But we're not going to do that. Okay, you're not going to be able to use your graphing calculator. So I need another approach. Well, the approach comes from the fact that we'll have a zero on one side, and the zero is very important. Now, before we talk about that, understand that with these quadratics, these graphs that look like U's, we may have two x-intercepts or two zeros or two solutions. U's sometimes only touch the x-axis and pop up. So sometimes quadratics will only have one solution. Sometimes quadratics we won't be able to solve. They will never cross the x-axis. And we'll have situations similar to what we did with lines, you know, intersecting in systems. Sometimes we'll have no solutions. Okay? Okay. So be ready for potential situations where there's only one answer, or there's two answers, or there's no answers at all. Most of ours that we will be doing in this class will have two solutions. All right. Here's the key. The fact that we have some equation equal to 0. We are going to use the zero product property to help us solve these. Because I know that anything being multiplied by 0 is 0. Zero times anything is 0. Anything times 0 is 0. That's important. And that's powerful. Products are powerful. Okay? Products are powerful when we're talking about zeros. Well, these are products. X minus 3 times x plus 7. That's a product. Okay? Now, what type of equation is this? Is this a linear equation? Is this like an absolute value? This is a quadratic. Why do you say that, Mr. Moore? Because whenever you multiply it out, it's got an x squared. This will be x squared plus 4x, right? We can just add the negative 3 and 7. We know the shortcut when we distribute. Minus 21. Well, this looks like this, okay? This is a quadratic. This is x squared minus 5x. Okay, well, this looks like this. Do you see where I'm going here? Okay, discuss with your neighbors where you think I'm going here. Where am I going? How are we going to solve this equation? Nope. Not yet. I don't know about it. It's not where I'm going. Doesn't exist yet. Doesn't exist yet. Okay. Here's the key, gang. Shh. We know how to turn this into this, right? Since I know how to turn this into this, if I asked you to find the roots of this equation, knowing that this starts as, and to find a root, this is very important, you're just assuming that we have an equation where y is 0. If I gave you this, 0 equals x squared plus 4x minus 21, at the beginning of class, you didn't know how to solve this. But if you turned it from this into this, and you know that when you get a 0, 0 times anything is 0, you should be able to figure out the numbers that make this right side 0. Discuss with your neighbors, what are the numbers that make this right side 0? Discuss. You're not saying it. 3 works, right? If I plug in 3, I'd get 0 equals 3 minus 3 times 3 plus 7. I know that this is 0. I don't care what 3 plus 7 is, because 0 times anything is 0. So 3 works. Negative 7 works, because if I plugged in negative 7, I'd get negative 7 minus 3. I don't really care, because I know I'll have negative 7 plus 7, so that's 0. This is something, this is 0, so this entire thing is 0. So if we have a quadratic in this form, a factored form, we can almost just see the answers. If I ask you to find the roots here, you're thinking, okay, find when this equation equals 0. What are our 2 answers here? 5 is one of them. Good, because if I plugged in 5, I'd get 0 equals 5 times 5 minus 5. That's 5 times 0. That's 0.
Is it not one of those one solution ones?
Is that it? Zardana, you say 0. Let's look. If I plugged in 0, well, if I have 0 times 0 minus 5, do I not get 0 times something? So this is not one of those one solution ones. There's actually 2 here. Why don't you guys try these guys? Now, I'm probably going to just do the one on the left. You guys can do the one on the right. Okay? I have a product equal to 0. All I need is a piece of the product to equal 0, and the 0 product property states that everything's going to be 0. So what we can do is set up 2 different equations. When this left piece equals 0, I'll have a solution. When this right piece equals 0, I'll have a solution. Go ahead and solve those 2. We are not here. We are over here. And then we skip a page, and we're already over here. Well, I could solve these. Minus 7 divided by 2. X equals negative 7 halves, or negative 3.5. Plus 12 divided by 3. X equals 4. This guy over here. Go ahead and find the solutions to this equation. One of them is easy to just kind of see. When x is 5, boom, we got it. Find the other one. So we see if one piece of the product equals 0, the entire thing equals 0. Okay? So what we are going to do is we're going to take equations like the first guy, and instead of trying to get x by itself, we will instead say, hey, leave that 0 there. That 0 is crucial. Factor this. So it turns from a sum into a product. How do we factor? Well, we do that whole understanding of the distribution of two terms, both leading with x. The two numbers that end up next to x, add to get the middle coefficient, and multiply to get the final coefficient. Two numbers are going to be 3 and -2. I would rewrite this as x plus 3 and x minus 2. Keep the 0 here. That's important. And after turning from this into this, from a sum to a product, we now can use the 0 product property to say, oh, -3 and 2 work in my original equation, and we visually saw -3 and 2. Isn't that neat? We're not going to be able to graph, though, in this class, so we're going to have to do it this way. Great. Now, that means we're going to have to factor. So let's remember how to factor. There's multiple ways we could factor. We could factor out greatest common factors. All of a sudden, I turn the sum into a product. We could use our number puzzle. Understanding that this in a product form is x plus something and x plus something. We want to figure out these two numbers. Well, we know that when we distribute, you got x squared, and then x times our second number, and then our first number times x. We ended up adding those together. And then our last term is our number times a number. So the two numbers will multiply to get 24 and add to get -10. Got to be -6, -4. We may have a difference of squares. This is 2x being squared. The thing is bugging out on me. This is 2x being squared. This is 5 being squared. I can write this as a difference of squares. Oof. 2x plus 5 and 2x minus 5. Remember that? Difference of squares rule, Mr. Manley? We could factor this guy. Here, we understand that my first term is not x and x, but we do know that it's two things being multiplied together. To figure out what it is, we're going to have to do a different number puzzle, incorporating that 6, changing kind of how we get the middle. So instead of two numbers that multiply to get 5 and add 17, we're going to look for two numbers that multiply to get 30 and add to get 17. If you did not do this problem correct, this is number 36 on your test, please write this stuff down and focus. We then figure out the two numbers, 10 and 3. We use those numbers to rewrite the middle term. Oh my goodness, 15 and 2. Good job. We then factor by grouping. I can pull out a 3x from my first terms. I get 2x plus 5. I already have 2x plus 5, but I'm going to make sure I know that I'm factoring out a 1 so that there is something when I pull out 2x plus 5. I then rewrite this as 2x plus 5 times 3x plus 1. We need to know how to factor something like this for this unit. Okay. We are now ready to solve quadratic equations. Before we go, tell your neighbors, what is the key to solving a quadratic equation where you have x squareds and x's? Discuss. What is the key? Having it equal to 0 is the key. The equal 0 is the most important part because we need to use the fact that this equals 0, and we're going to turn products, we're going to turn sums into products, and then we can just find when pieces of the product equal 0. This is a sum. I've just turned it into a product. Now I think, what numbers make each piece of my product 0? Because if I have one thing equal to 0 times something, everything is 0. And I think -5 would make this thing 0, making everything 0. -2 would make this thing 0, making everything 0. I have solved this equation. I did not try to isolate x. I did not square root. I did not do anything that your first instincts told you to do when we first looked at a quadratic. We used a different approach. We have equals 0. We turned a sum into a product. We then found when each piece of the product equals 0. So let's do this next one. And do the third one. Yep. 12 and 2, not 6 and 4. So we turn this x minus 10x, x squared minus 10x minus 24 into x minus 12, x plus 2. Then I say, well, when x is 12, everything's going to be 0. When x is -2, everything's going to be 0. Sometimes, like, you don't believe this, and sometimes this seems like magic, but like, in a calculator, take 12, square it, subtract 10 times 12. Subtract 24, 0. Take -2, square it, subtract 10 times -2, subtract 24, 0. We found the solutions just using an alternate approach. We see this guy. Probably most of you are probably thinking about multiplying 4 and -32. Don't do it. There's an easier way to go about this. What should I do? Yes, factor out the greatest common factor. Each of these share a 4. Get rid of the 4.
You can do it either way.
You could do it either way. No, for the first two you couldn't do that. But for this one, it will make the problem much easier if you factor out the greatest common factor. Now, I could factor this to be x plus 4, x minus 2. Those are the two numbers that add to get positive 2 and multiply to get negative 8, right? This is equal to 0. Giving me solutions. Negative 4, because negative 4 plugged in here would make this 0, make everything 0. 2, because 2 plugged in here, doesn't matter what happens here. This is 0, everything's 0. What about 0? 0 solution?
No.
Everybody think about that for a second.
0 minus 2 would be negative 2. That would be 0.
Yep. Some people think that because we factored out this 4, that 0 is now a solution. No. If I plugged in 0 for x, I get 4 and negative 2 times 4. This is not a solution. Okay. Let's look at this guy. Tell your neighbors again. What is the key to solving these quadratics where we have x squareds and x's?
Equal to 0.
Equal to 0. Is this an equation where things are equal to 0?
No, not yet.
Not yet. That is the key. We may have to solve or put everything to one side so that we had 0 on the other side. Make sure we have equal to 0, which means get rid of the 30x, subtract it from both sides, and subtract the 60 from both sides. Rewrite the equation as 5x squared minus 30x minus 60 equals 0. Factor out big old 5.
Wait, why did you change the sign?
Because I'm using algebra, Mr. Pottsworth. I don't just move stuff. To remove that 30x from the right side so that it goes to the left side, I have to subtract it.
I moved the 5x to the right.
You could move the 5x to the right. It's fine. I haven't moved everything to the left because I like this to be a positive.
Yeah.
Good call.
Yeah, I did that,
But
I changed it, but I took out a negative 5.
good. If you move the 5x squared to the right side and you have a 0, just make sure you take out a negative 5 so we have a positive x squared after we pull stuff out. 6x negative 12. This isn't going to work out, guys. Turn this to a, if I make this a 35 and this becomes a 7, then, yeah, but then the negative, no, I'm just going to change the problem. This is a bad problem. But no, let's just pause here. This is a good spot. I got it equal to 0. I looked to factor this. I can't. Maybe there's no solutions. Maybe there's still 2 solutions. We're going to have to investigate further looking into next class, okay? Let's pretend this is different, though. I could turn it into a 35 and a negative 60, meaning this would turn into a positive 60. This would still be negative 35. When I factor that 5, this would be negative 7x, and this would be plus 12. Now I can factor. Minus 3 minus 4. There's my 2 values. I got 2 solutions. That means there's 2 zeros if I graph that equation. Well, let's look at this guy. Does 2x squared and 72 share something?
2.
A 2. Pull out the 2. How do I factor x squared minus 36? Discuss with your neighbors. It is a difference of squares, x plus 6, x minus 6. It's the 2 numbers that multiply to get negative 36 and add to get 0. Meaning, if I plugged in 6 or negative 6 to that equation, I'd get the correct answer. Look at the next guy. Can I pull out anything from 9x squared and 4 that they share? Nope, but I can factor this. It is a difference of squares. Factor it. Find the solution. See if you can do it. Check your factored form with a neighbor. Check your solutions with a neighbor. It's not disappearing on us. It's not going to go away. You're missing it. You're missing a key thing here. You're missing a key thing. No, I'm saying you're missing a key thing here. You're missing a key thing here, and a key thing here, and a key thing here. But you have it here. So I believe you know. Three x plus 2, 3x minus 2. That means I can't see it automatically. Make sure you have the equal 0. Take each piece, set it equal to 0. Solve. Subtract 2, divide by 3. X equals negative 2/3 here. Well, x will equal positive 2/3 over there. If you take 2/3, square it, multiply it by 9, subtract 4, you will get 0. If you take negative 2/3, square it, multiply it by 9, subtract 4, you will get 0. I guarantee. Next ones. X squared equals 8x. Do I have x squareds and x's? Yes. So this is a quadratic. What should I do? What is the key to solving quadratics? 0 on a side. Subtract 8x from both sides so that you have one thing equal to 0. So we subtract 8x, we have x squared minus 8x equals 0. How should I factor this? Yes, pull out an x. Pull out the greatest common factor. And write your solutions. You see this x over here? This is a product. This is part of the product. So if I plug 0 in for x, that's 0 times anything, 0. It'd be 0 times negative 8. So 0 is a solution. And 8 is a solution. Do the second one. Negative 5. Okay, now think about it. What makes the pieces 0? 5 doesn't make this 0. It'd be 5 plus 5, that's 10. I want this piece to be 0, negative 5 plus 5 is 0, times negative 5 is 0. All right, so those are the easy factored ones. Let's get into the harder ones. Let's review factoring when a is not 1. Now notice the way I'm asking you this question. I did not start out with an equation, okay? I said find the zeros to the quadratic function. That means you are going to solve this equation. Zeros are when y is 0. You replace y with 0. Okay, let's go ahead and factor that. Because we are not 100% sure that we're going to get x times x, because we're not going to get x and x as my first things, we need to manipulate our number puzzle, multiply a and c first. And you're thinking, what two numbers multiply to get negative 8 and add to get 7? You then take those two numbers and rewrite the middle term. You then factor by grouping. Find the two numbers that multiply to get negative 8 and add to get 7. Rewrite your middle term using those two numbers. Factor by grouping. And my pen does not like the smart document camera. You get that, right? One solution, readily apparent. X equals negative 2. The other solution, I may have to do some work for. After you've done enough of these, you can tell exactly what this is going to be. But the other solution comes from when this is 0. Add 1, divide by 4. Okay? See the guy on the right. Very, very strange indeed. Now, we're all caught up on remembering how to factor when a is not 1. We see another one where a is not 1. We've got a 6 here. All right, multiply 6 and that. Wait. Don't just jump into the most difficult type of factoring. Look to see if we can factor out a greatest common factor first. Make life easy on yourself. Don't do this factoring by grouping AC rewrite method unless you really have to. Do the same for the one on the right. Don't multiply 2 and 162. That'd be the tough way to do this. It would work, but instead, factor out the greatest common factor. That's not 31. I got 2 times x plus 9 times x plus 9. That's x plus 9 squared. So that means my 2 solutions are -9 and -9. Does that make sense? Yeah, this is the same thing. Just -9. What is that telling you about the graph of y equals? Yes, it only has 1, 0. It only touches the x-axis. Okay? That was our only example where it was like that. We haven't done any examples where it doesn't touch because all of these are factorable. But if you ever see one that's not factorable, we will discuss next class what we would do from there. No, we would not, because we're not allowed to. Okay, that's out of the question. Finish with these two. Now, before we get started, it says find the roots of the quadratic function. Zeros. Same thing. Okay, just make sure you understand a root is the same as a 0. Is the same as when y is 0. It is a common thing on tests on the CLEP exam for you to be asked to find a 0. You need to understand what that means. You may be asked to find a root. You need to understand what that means. Root is a 0. It's when y is 0. All right. Oh, that's cool, huh? Sorry. Maybe I got to solve one of these. Maybe I'm unsure what it is. Take the time. Subtract 2, divide by 3, negative 2/3. You wouldn't write it twice. This is another one where we just have one solution. Okay, we just touched the x-axis. Last guy. We got 3 minutes. Come on. I'm going to come around and make sure we all have this done. Let's go. Let's go. Factor it. Let's do the bottom right guy.
All right, I will.
15 and 4 are the numbers. Okay, guys? We can't spend the rest of the class. 15 and 4 are the numbers that we are looking for. Positive 15 and negative 4. Stuff isn't disappearing on us. Factoring did not disappear on us. Okay. Solving quadratics, we need a different approach.